Hello and welcome back to the Cracking Pang YouTube channel. Today we are solving yet again another interval problem, this time number 57, insert interval. You were given an array of non-overlapping intervals, where intervals of I equals start of I, end of I, representing the start of the and end of the ith interval, and intervals is sorted in ascending order by start of I. You were also given an interval, new interval, which has a start and end, which represents the start and the end of the new interval. You want to insert new interval into intervals such that intervals is still sorted in ascending order by start of I, and intervals still does not have any overlapping intervals, and you are asked to merge overlapping intervals if necessary. We are asked to then return intervals after the insertion. So if we have this example here, and kind of let's just draw it out on a number line. So if this is 1, let's just say this goes up to 9. So 2, 3, 4, 5, 6, 7, 8, 9. Okay, that is roughly a 6. Okay, so we have our first interval from 1 to 3. Ooh, that's really bad. 1 to 3. We have the second interval from 6 to 9, and we're asked to insert the interval 2, 5. So we can see that this is here. Oops, not to there. 2 to 5. Okay. So how would we do this? Well, obviously, if we were to insert this interval here, it would overlap with this one. And we're asked that there's no overlapping intervals and that they're still sorted. So in this case, we need to merge these two intervals. And we've done this problem before. Basically, to merge it, we take whatever the kind of leftmost starting point is and whatever the rightmost starting point is of the two intervals, and then squash them. So now our interval becomes 1 until 5. And then obviously there's no overlap with the next interval, so we don't have to do anything there. So we can just leave it as it is, so 6 and 9. Now this example is quite long, but maybe we can actually do it. Oh boy, I have to draw out a new number line here because this thing goes up to 16 now. Okay, that should hopefully be long enough. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Oh boy, 12, 13, 14, okay, 15, and 16. So we have this example, and just to do it visually, okay, so we have, what are the intervals? From 1 to 2, we have 3 to 5, 6 to 7, 8 to 10, and 12 to 16, and we're asked to insert 2 to 5. So obviously, if we were to insert 2 to 5, then this would overlap with this interval, so we need to squash them, which becomes the interval for 1 to 5, which actually also encapsulates this one, so we would just merge them, so to get rid of this one because it's overlapping, so this would just become the parent, so it would still just be 1 to 5, so this interval would kind of just go away. Oh, actually, no, wait, hold on. Oh, wait, oops, I was inserting the wrong interval, so, whoops, I was looking at the previous example. So this is 8 to 10, sorry about that, so this should be 12 to 16, and we're inserting 4 to 8, so 4 until 8. So with this one, we merge these two, and obviously this covers this one, so that it would get absorbed, so this one would go away completely. So we still have the interval from 1 to 2, that one is fine, but then we need to merge these ones, so this becomes 3 until what? So it goes all the way to this one, but then they intersect, so we need to merge it again, so we'll merge and take the endpoint here, so it's 3 to 10. And then the one from 12 to 16 is on its own. So that is kind of how they got that one. So this question, obviously looking at it, is relatively straightforward, and the solution to it is pretty intuitive. Let's see if I can just remove it. And there's really 3 cases we want to handle here, and this is the insert at start. So this is the case where our interval actually comes before the first interval in our given intervals, in which case we just need to put it at the front, and that's all we need to do. The second case is the insert at the end. Insert at end. In which case our interval is so far to the right that it actually does not interfere with any of the other ones. So we just insert it at the end and we're done. The third case is where we actually need to merge some intervals. So the merge can happen at the beginning. We need to merge. We could potentially need to merge at the end or somewhere in the middle. And then we need to merge and basically reduce the intervals to get rid of any overlaps, kind of how we did in the problem merge intervals. So those are the three cases you want to handle. The one where you have to insert it at the very beginning, the one where you have to insert it at the very end, or the one where you insert it at some point. Maybe it's at the start, maybe it's at the middle, or maybe it's right at the end. And then you need to merge down your intervals to make sure that you follow the condition of no overlapping intervals, and you merge where necessary. So those are the three cases we want to handle, and once we go to the code editor, we'll see how we actually handle those three individually. So let's do that now. So we went over some examples, we went over the solution intuition, and we went over the three cases that we basically need to solve for. So let us actually solve this question. The first thing that we want to do is, if there's no intervals for us to check, then we just return whatever the new interval is on its own, because then we don't need to insert anything really. So we're going to say if not intervals, we're just going to return the new interval, right? So pretty simple. Okay. Now what we want to do is remember that we're going to be basically just checking each of the intervals, and we're going to do this from left to right. So we're going to say that the current index is 0, and we need to define a result variable to basically store our result here. Now what we want to do is we actually want to check the first case, where do we actually want to insert it at the beginning, or maybe we want to check it at the end. And here's how we're going to do that. So we're going to say while the current index is less than the length of intervals. Obviously we don't want to have a out of bounds exception, and the start of our new interval is actually too big, then we want to just add the intervals that we can, right? So we're going to say if the current interval that we're processing, so intervals of whatever the current index of 0, so if the start of the interval that we're processing in intervals is actually less than the start of new interval of 0, so basically before the start of our new interval, then we know that there's no overlap here, so we can simply just add whatever the interval is to our result, because that means that we don't have to insert our new interval yet. So we can just keep adding it. And remember, this works because we are told that the intervals are sorted in ascending order, so that's why we can do this. Okay, so if this is the case, then we simply just append the current interval. So intervals of cur index, we just add it to our result, and then just add 1 to the current index to move forward to the next interval. So when this while loop breaks, one of two things will have happened. Either we're now at the end of the array, or we actually never got to even start, because actually the interval needs to be inserted at the beginning of the array. So let's check those conditions. So we're going to say if not res. So if res at this point is empty, that means we haven't appended anything to it, and that is because this thing didn't fire, which means that we actually need to insert the new interval at the beginning. So if we have a result, if result is empty, or actually we just got to the end of the array and it turns out that our new interval actually doesn't even overlap with the last element, then we just need to add it to the result. So in either case, we need to just add our value. Either it's going to be the very first thing that we put into res or the very last thing. In either case, we can just append to it, and it's fine. So we're going to say, or if the last element in res, its end position is actually before the start of our new interval, then that means that there's no overlap at all. And this is the case where it's at the end that we need to insert it. And this is the case where actually you need to put it in the beginning. So if that's the case, then all we need to do is just say res.append our new interval. Otherwise, what we need to do is actually, for the last element, we now know that there's a problem here, because we need to double check that where we're inserting our interval is actually going to, we need to just take, sorry, let me take a step back. So this is the case where we insert at either the beginning or the end. or that means that we now need to insert it, and we need to actually check that we actually get the new bounds of our interval right, because we're inserting them, so we need to take the start and the end position accordingly. So we're going to say that the last thing that was inserted, we need to adjust its end position based on the end position of either this current interval or our new interval's end. So we're going to say res -1, 1. So it's the new end of our last thing that we added to our result is going to be the maximum of whatever the current end position is and the end position of our new interval, similar to how we did in merge intervals problem. Okay, now we have inserted our interval. Either is at the beginning of the array, it was at the end of the array, or at some point in the array. And we've now merged those two intervals to make sure that we have the merge thing. But now that we created this new interval by merging whatever some interval with our new interval, we may have an overlap later on in the actual problem. So now we need to handle any of those lingering overlaps. So we just need to continue through our processing and actually finish it. So we'll still have cur index at some value. Now we need to just continue until the end of the array and actually process everything and add it to our result. So we're going to again say while the current index is less than the length of intervals, now we basically just have a merge intervals problem, and we've done this before. We're just going to say that the current interval is again equal to intervals of current index. We're going to say if the start of our current interval is at, if the start of our current interval is actually less than or equal to the end of our last interval, that means that we have an overlap and we need to handle this. So if this is less than, so res -1 will give us the last interval we have, and then the first position will actually give us the end of it. So if the start of our current interval comes before the end of the other one, that means we have an overlap. So for example, if this was like the interval 1, 3, and then we had the interval 2 to 5, right? So 2, its start position is before the end of the other one, so that means that there's an overlap, and we need to combine these two into 1 to 5. So that is that case. So if this happens, then again, the new ending position is going to be the maximum of the two ending positions. So as we just saw in that example with 1 to 3 and 2 to 5, obviously it would be 5 after we merge it. So we're going to say the current interval of whatever its endpoint is and whatever the current end interval's endpoint is. Okay, so that is that. So this is the case basically when it's equal to that we would use this one. So okay, so otherwise, we know that there's no overlap here because we just checked whether or not there's an overlap between the start and the end. If there's no overlap, we just append whatever the current interval is and continue. So in the case that we basically inserted at the beginning, all we're going to end up doing is just... Actually, no, sorry, we can still fix overlaps, but yeah, there's a chance that there actually are no overlaps, so we just basically just append the interval. I'm confusing myself even, so otherwise, yeah, let's just increment the index at the end of all of our logic here and continue until basically we hit the end of whatever the length of intervals is. And then at the very end, all we need to do is just return our result, and we are done. Let me make sure I didn't make any little mistakes here. Cur interval. Oh boy, did I? Cur interval. Great. Can't type today, can't spell today. Okay, there we go. At least it now should be accepted. Perfect. Alrighty. So, what is the time and space complexity? So as you can see, in the worst case, we're going to basically parse through the entirety of intervals once. And, we may have to do some merging logic, but all of that happens kind of in place. So our time complexity is big O of n, where n is the number of intervals in intervals. So for the space complexity, we have, well, it's a bit complicated. So technically, it's big O of n because we need a result array. We can't, we can't overwrite the original array. So technically it's big O of n because we have this new array, but some interviewers will just call this, but maybe big O of 1, because we need an array for the solution. So in this case, sometimes your interviewer will let you just call it big O of 1 because, I mean, you can't not return this list here, so you're not using extra space. This is just what you need for the solution, but technically it's big O of n because you need to store the result here. But you could say, I mean, the best way to say it, it's big O of n because we have the result array, but since we need it for the result, it's technically big O of 1 because we don't actually create any extra space other than what we need for the result. Anyway, that is how you solve insert interval. Like you see, all of these interval problems are very, very similar. This one is basically a combination of merge intervals and whatever the other one was, I don't remember, interval insert index or something like that, where we're basically just checking start and end points, merging intervals, and continuing forward. So pretty straightforward. Remember that there's 3 cases in this problem: inserting at the beginning, inserting at the end, or inserting somewhere in the middle, and then needing to handle all of the overlapping cases because we're not allowed non-merged arrays here. So that is how you solve this problem. Hopefully this video helped you. If it did, leave it a like and a comment. It really helps me grow the channel. Why not subscribe as well? And I will see you in the next one. Bye.